To the session. I'm Yueming, Senior Program Manager from Azure Storage Team. Our session is on optimized price performance and lower TCO for your workloads with Azure Disks. So who is here to save cost? Okay, I see a few folks are not interested in saving cost. Interesting. I need to know you better. We seldomly find customers who are less interested in cost saving. Okay, let's get started. To set the stage, why are you using Azure Disks? So Azure Disk is the best value persistent storage for your business critical workloads. It is performant, durable, available, and flexible. So one of the key reasons for you to move to cloud is to save cost. However, saving cost is not easy, especially that you have storage appliances from on-premises. Those can be SAN arrays, HDDs, SSDs, and different types of storage appliances. When you move to cloud, so sometimes you're not able to construct it well in a way that it is cost efficient. So we hear you say that how to choose between premium and standard SSD. I need smaller disk sizes for my Linux OS. I don't want to provision for peak IOPS. Can I scale up my disk throughput only when needed? Can I buy reservation for disks similar as VMs? So my goal today is to ensure that by end of the session, you will have an answer of all these questions and comments above. So how to achieve cost efficiency? We would like to look into this from 3 steps. First, choose the right disk offerings. We have 4 disk offerings where they are tailored for different types of workloads. It is very important that you actually find the disk offerings which best match your workload. Second, choose the optimal disk size. So this is not only about capacity, it's also about performance, where you need to ensure the disk IOPS and bandwidth can also fit what your workload requires. Then we have the third step, which is most important, leverage Azure unique capabilities. You would like to think as whether your workload is leveraging some unique capability of Azure so that you'll be able to achieve price, performance, and cost efficiency. Let's get started. We'll start with selecting the right disk offerings. So Azure provides you the most comprehensive disk portfolio, ranging from standard HDD to Ultra disks. The underlying hardware and software technology determines the performance characteristic and also the price point. We have our most cost-efficient storage on HDD, ideal for backup type of workload. Then we have entry-level SSD, where we offer the lowest per GB price SSD on the cloud. It is good for entry-level web service, which you actually don't need super high transactions. Then we have premium SSD. So this is what we recommend as a default disk option because it provides the best balance for cost and performance. It is very suitable for database type of workloads where you need high IOPS and bandwidth with semi-linear growth with your disk capacity. Last, we have Ultra Disk. This is what we announced GA August. It is the fastest disk on the cloud platform where we provide you the most flexible cost model. Because for Ultra Disk, we provide very good scalability so that you'll be able to customize your IOPS and bandwidth per size. Now that you have a good understanding of how different disk offerings maps to the different workloads, I would like to share a few key considerations you should keep in mind when you are defining your requirements for the disk storage. Many of those may look very straightforward, but we found it can be commonly overlooked in practice. Number 1, what is your availability target? Depends on your availability target and the nines you wanted to hit in the availability SLA. It can influence your choice of the disk. For example, if you have a workload that is a backend server, which you cannot scale it to multi-instance, you need a disk, you need a VM that can provide you single instance SLA. In that case, it will land on using Ultra Disk or Premium SSD. On the capacity and performance perspective, one very common pitfall that we see is that instead of defining your requirements based on the workload, you happen to define your disk storage requirement based on the storage hardware. So it is very common that from on-premises, you buy a storage appliance. You first put your SQL workload. Then, if you have space, you start putting your scale-out file server or even your backup there. But when you're migrating it to cloud, you migrate on a per workload basis. Let's say you're migrating your SQL. It is very important that you capture the performance and the capacity characteristics specifically for the SQL workload instead of just simply matching the hardware spec. Because if you match the hardware spec, in many cases, you are over-provisioning, which ends up probably paying more on your cloud implementation compared to on-premises because you're not looking at a per workload basis. So I've shared with you all the key considerations that you need to keep in mind. I know it's very challenging to take consideration of all these factors. We have great tools built for this. So I'm going to welcome Sneha on stage from Azure Migrate team, where she will share how Azure Migrate can be a best solution for this.
Awesome. Thank you, Yumin. Hello, everyone. My name is Sneha Agrawal, and I'm a senior program manager on the Azure Migrate team. So how many of you know about Azure Migrate or have used Azure Migrate in the past? Awesome. That's quite a few. Yeah, so for those of you who don't know about Azure Migrate, let me walk you guys through what it does. As you might know, migration is a journey to Azure. It's a 4-step journey that starts with assessment of your on-prem workloads, which is super crucial because not every workload is designed to be run on the cloud. So you need to discover your workloads, scan them, and really understand whether your disks are suitable for running on the cloud or not, whether your VM is compatible with Azure or not. So we help you assess your on-prem infrastructure and identify whether your VMs on-prem, whether your disks on-prems are suitable for migrating to the cloud. Once you are ready with a solid plan, you move to the migration phase, and this is where you do the actual move, where you move your VMs maybe using a rehost approach or a refactor approach. And we have tools available in Azure Migrate that can help you do that. Once you have completed your migration, the journey does not end there. You will have to continue to optimize your Azure resources. So you need to continue to optimize your disks, your VMs, and make sure you save on cost and latency. Lastly, you also need to continue to manage your resources on Azure, and you need to make sure that they are securely running on the cloud. So Azure Migrate helps you in the first 2 steps of this journey. For the other 2 steps, we already have a bunch of offerings in Azure that you can leverage. So let's look at Azure Migrate. Azure Migrate is a central hub for migration. It provides you tools that you can use to start, execute, and track your migration journey. If you've used Azure Migrate a year back, it was just an assessment tool, but we have upgraded it. We did a major release in July this year where we made it a hub of migration tools. So what you will see in Azure Migrate are tools available for various kinds of workloads. We have tools available for assessment of servers, assessment of databases, and for migration scenarios of web applications, virtual desktops, and so on. So no matter what kind of workload you have, you can find a tool in Azure Migrate that you can use to migrate that workload to Azure. We also provide integrated experience between various tools. So if you're using different tools for assessment and a different tool for migration, you can bring in the assessment recommendations into the migration tool without having to do any manual effort. Additionally, we also provide you choice of tools. So we understand that every customer has a different requirement, and the same tool cannot fit every customer. So we have integrated with multiple ISV tools so that you have options. And depending on your requirement, you can choose a tool that really fits your scenario, and you can accelerate your migration accordingly. Last but not the least, Azure Migrate also provides you end-to-end progress tracking. You can use it as a single pane of glass to really track your migration journey across all the various steps. Now, when it comes to disk assessment, Yumin spoke about a few of the considerations that you need to keep in mind when you are running disks on Azure. So we have a tool in Azure Migrate called Server Assessment that you can use to do the same. The Server Assessment tool discovers your on-prem virtual machines and the disks attached to your machines, and it assesses them to identify the right VM size and the right disk type in Azure for you. And there are 2 kinds of sizing that we do in Azure Migrate Server Assessment. The first one is the performance-based sizing, where we look at your on-prem performance data and allocate a VM SKU in Azure for you and suggest a disk SKU in Azure for you. And this is important because many a time we over-allocate our resources on-prem. We may not be needing a premium disks in Azure because our IOPS are low. If you do not do this assessment, you may allocate a premium SKU in Azure and you may end up paying more. So we strongly suggest you to do this assessment to really understand what do you exactly need and how can you leverage the server assessment tool to identify the right SKUs for you. The other sizing, the second option that we have is as on-prem sizing. If you do not want to do a performance-based sizing, you can always do an as-is sizing where we will not look at your performance data and recommend the VM SKUs. So let's start with the performance-based sizing option. So here, when it comes to storage sizing, we look at each disk attached to your VM, and we look at the read and write IOPS of each of your disks, read and write throughput of each of your disks, and based on these requirements, we recommend a disk type in Azure for you, whether you should go to standard, premium SSD, and so on. And depending on the size you need, depending on the IOPS and throughput you need, the SKU within the type is also recommended. Additionally, we also do the VM sizing or the compute sizing. So based on the disk we have recommended, if we have recommended a premium SKU to you, we will make sure that the VM SKU recommended is compatible with the premium disk we have recommended. For compute sizing, we also consider CPU and memory utilization, and we marry the storage and VM recommendations to recommend a combination that is compatible and that meets your on-prem requirements. So that's about performance-based sizing. We strongly recommend you to do that because you can save a lot of cost. And from our assessments that we have seen from customers, we have seen customers saving 70% of their resources when they are going with the performance-based sizing approach. The second option is as on-prem sizing. There is a simple difference between the both. If you go ahead with the as on-prem sizing approach, we will not look at your performance data, so we will not look at your read, write IOPS or throughput values, and we just look at the size of your disk, and you need to tell us the disk type to which you want to migrate, whether it's premium, standard SSD, or HDD, and we will pick a SKU based on the size of the disk. And the rest of the steps are all same. So let me switch to my demo environment, and I will quickly show you guys how you can leverage Azure Migrate to do this assessment. So I'm going to switch to my demo machine here. And what I've done is, in the interest of time, I have already created an assessment on top of some of my machines. An assessment helps you identify the readiness status of your on-prem virtual machines for migration to Azure. So the first chart that you see here tells us, hey, you have assessed 9 virtual machines, and 7 of them are ready for migration, but 2 of them are not ready to be migrated. And when you drill down into this chart, you will understand why these VMs are marked not ready. To give you some examples, let's say you have an on-prem VM with a disk attached to it which has a size of 100 terabyte, which is clearly not supported on Azure. So if you have such disks, we help you identify such issues, and we provide you remediation guidance regarding how you can fix those issues. So the Azure VM readiness column lists all the issues that you have, and it provides remediation guidance regarding how you can fix them. Additionally, you can drill down at a per VM level, and you can look at all the disks attached to the VM, and you will see that we have collected performance data about IOPS and throughput, and based on that, you will find the disk SKU that is recommended for you. So you can really use this tool to find out what is the right SKU for me versus going for a premium SKU when you don't need one. The same is done for VM sizing, where we recommend a VM SKU based on the performance data of your VMs. And the assessment comes with a bunch of properties that you can play around with to customize it for your own requirements. If you're particular about going to, let's say, premium SKUs because you have a mission-critical application, there is a storage type filter here. It is set to automatic by default. But if you are particular about a different certain type of SKU, you can select it accordingly, and we will make sure that our recommendations are done based on your selection. So that's how you can use the Azure Migrate Server Assessment to do a quick assessment of your on-prem environment. And this tool is free of cost, so you do not have to pay anything when you use it. You simply have to go to the Azure portal, and you will find it there. Now, before I hand it over to you, Min, to talk about some of the new capabilities we are adding to Azure Disks, let me quickly provide you a brief overview of our roadmap when it comes to the server assessment tool. So we've seen what is available today, and at Ignite, we are announcing support for some new scenarios where we are supporting physical servers, adding agentless dependency visualization, and so on. In future, very soon, we will add support for Ultra Disks. So if you've noticed the demo, we only support premium, standard SSD, and standard HDD disks now, but very soon we will start supporting Ultra Disks. And we will add all the new goodness that's going to be lighting up in our Azure storage platform, like share disks. We will start recommending users to do disk striping, and all the new SKUs that Yumin is going to talk about will also be supported in Azure Migrate. So let me hand over back to Yumin, and she's going to talk about all the cool features that we have in Azure Disk.
Thanks, Neha. I think we will have time for Q&A. We'll stay here, and if you have any question, we can address it then. Thank you. So let's move to the next part, choosing the optimal disk size. So currently, we support disk sizes from 4 GB up to 64 terabyte. So for premium SSD and standard SSDs, it starts with 32 GB. So we have heard your feedback that you need more smaller sizes to address your smaller data footprint. So today, we're announcing the preview of smaller sizes of 4, 8, and 16 GB on both premium SSD and standard SSD. It's going to be ideally used for workloads like OS images, which you have smaller Linux image, and you can use it to store user profile data for your VDI environment. Or you can even use it for log files for your small database. It is currently available in West Central US, and we are in the process of rolling out to more Azure production regions. Well, size is not only about capacity, it's also about performance. Here, I would like to show you the disk IOPS captured from an active disk running in Azure. You can see that over this 3-hour window, the baseline IOPS of this disk is roughly around 500, where the max can peak up to 1,300. The question what I often hear is that, should I provision for peak or baseline? It is as if I'm asking, like, how should I trade off between performance and cost? Well, why would you need to do that? Today, we would like to announce our preview of our disk bursting, where you'll be able to get a performance boost on your disk up to 30 times. It is a credit-based bursting system. Enabled by default is a platform improvement. You don't need to do anything on your end. We support bursting on both IOPS and bandwidth. It's supported on premium SSD for size up to 512 GB. You can burst up to 3,500 IOPS and 170 Mbps. So with bursting, you can optimize for both performance and cost. It provides better tolerance for spiky type of disk traffic. I would like to go into a bit more details to explain with you how this credit-based bursting works. So let's say I have a P4 disk. It has a provisioned IOPS of 120. Let's say in the first second, I don't have any disk traffic. So I'm going to accumulate the credit. So at the start of every second, you get additional credits based on what is the provisioned rate. So in this case, my disk is provisioned for 120 IOPS, so I get 120 credits. Then, in the next second, I'm going to hit my disk as 120 IOPS. So basically, hit exactly at the provision IOPS. So my credits in the bucket remains 120 because I got 100 and then I spent 120. In my third second, there's no more disk traffic, so I accumulate additional 120 credits. Then I'm going to issue 360 IOPS. So basically, it's going to drain all the credits from my credit bucket. So this is an abstraction of how bursting will work in a simulated scenario. So it's kind of a representation of what you can see on usually a database log file, which basically they have spikes during disk flushes, and you can see this spike, and then traffic goes down. I'm going to put it in the actual scenario that on the disk I show you. If you look at the first stage, this is the stage which you accumulate credits. So you're accumulating a credit at the rate of your burst IOPS, of your provision IOPS and bandwidth, because the disk traffic is way below the provision limit. In my next stage, my disk traffic is going beyond my provision IOPS, so you start consuming the credit which you previously accumulated. Then on the third stage, you start accumulating credits again because your disk is mostly idle here. So there is a maximum on the credit that you can accumulate, which is basically a cap on the burst on your credit bucket. This determines what is the maximum duration you can burst at the peak rate. Let me take an example as what it means. So if you have a P4 disk, your max bursting duration is 30 minutes. 30 minutes means that you can burst at 3,500 IOPS for a duration of 30 minutes. But let's say you burst, but you don't go to the maximum. Let's say you just burst for 1,000 IOPS. In that sense, you'll be able to burst for a much longer duration than the 30 minutes because you are consuming your credits at a lower rate. Now I have explained to you how bursting works. Let me show you in a real demo. So let's say I started a part-time job where I opened a Contosa hotel. So it's a small, reasonable-sized hotel. I built my own website for this. So the website is running on Azure Web App, where I'm using MariaDB as a database backend. In the database, I'm basically making I pass the record of all the reservations for the rooms and then the room availability. So let me take a look of what is the Azure setup for the MariaDB. So if you can see here, the database files that I have for this MariaDB is now on this burst disk. It's on the premium SSD and 32 GB. I'm going to click on it and show you what is the performance target. You can see right here that from the disk configuration that my IOPS and throughput of this disk is 120 IOPS and 25 Mbps. So it's not very high, but it's sufficient for my application because I probably have less than 100 customers coming in and make a reservation. So it's good enough for my average workload, and it's very cost efficient as I have a very small disk footprint. However, just today, the stadium right next to my hotel announced that they are going to host a huge music festival. So at that point, people around the world wanted to come to this festival, and they're trying to book a room. So there will be an increase of traffic coming into my website, hitting my MariaDB, trying to make a reservation. So I'm going to run a simulation right here, which does exactly that. So this simulation basically does is that it hits my MariaDB, and then it tries to do read, which you're trying to query the available rooms in my hotel. While the higher traffic is coming into my website, I wanted to make sure that every customer still have a very consistent and smooth room reservation experience. So let's give it a try right here. So I'm going to check availability. You can see that all the available rooms are now returned. I'm going to just select the first room and do a checkout. I'll click on reserve. You can see that my reservation is pretty smooth. Like you're not waiting there for the website to come back to me as checking on the room and waiting for the reservation to be completed. I would like to show you what is happening on the back end. So you can see right here, on the disk, on the I/O stats measured on the disk, you can see that while I'm doing this reservation, the backend disk is actually getting disk IOPS up to 3,500. So while there is a lot of traffic coming in, hitting my website, hitting my MariaDB, I'm still being able to provide a very good user experience to the customer, leveraging bursting. So with this bursting, we are able to better accommodate for traffic spikes. What it means for you is that you don't need to provision for occasional peaks or spike of traffic, where you can take advantage of Azure Disk bursting capability and provision for your baseline. I've shared with you the new feature announcements on small disks and disk bursting. I recommend you to take that into consideration when you are defining what is the optimal disk sizes for your workload. So next, let's take a look at how you can leverage the Azure unique capability to save your cost. I would like to look at it from 3 aspects: durability, flexibility, and also pricing. From a durability perspective, Azure Disk provides this industry-leading annual failure rate of 0%, and we have the promise of not losing any customer data. Well, you may start to wonder, how does durability have anything to do with saving cost? Well, look at what you're doing for on-premises for durability. So it's very common for on-premises, you have RAID implementations so that you can ensure that your disks are durable. Let's just take RAID 1 example. Basically, for RAID 1, what you're doing is that a 1 terabyte disk, if you need 1 terabyte volume, you need 2 1 terabyte disks, one for imaging of the other, so that if one of the disks is corrupted, you still have the data on the other disk. While on Azure, all the disks are supported on local redundant storage. What it means is that every write you write to the disk, they are synchronously committed to 3 replicas. And we only return to you write success when all 3 replicas has committed the data. What I mean by you is that you can go and look at what is your durability requirement for the workload and reassess whether you still need a RAID implementation for durability, or can you leverage the native capability provided by Azure. If so, you have an opportunity to reduce the unnecessary replication cost. Next, we'll go into flexibility. Whenever you think of flexibility, the top thing that comes into your mind is that I want to scale on demand. So yes, dynamic scaling of provision performance is a way for you to save costs. So I would like to share with you a TCO comparison done on Ultra Disks, which share the comparison between a static provisioning compared to dynamic provisioning. So if I take the traditional static provisioning model as an example, so I'm hosting a trading system. So I need a disk which can handle very high transactions. So at the peak, I'll need a disk, let's say 1 terabyte with 10,000 IOPS. But if I look at the dynamic provisioning, I only need such high IOPS and bandwidth during my business hour. When it's off my business hour, I can fine-tune and tune down my IOPS to a much lower rate. With that, I can achieve a cost saving of 42%. Dynamic scaling is now supported on Ultra Disks. You can scale both your IOPS and your bandwidth. I hope by now I'm able to convince you that dynamic scaling will be able to give you potential savings. Your question will be, so how could I orchestrate that? There are different ways to do this. Here we are going to recommend using Azure Function App. You can set your triggers either based on the schedule time or the disk metrics. Let's say you're doing game hosting. So you know that during weekends, people are going to come in and play the game. So the disks where you're using to store the gaming titles, you need the higher transactions and bandwidth to be able to address the traffic. So then you can set your time as Friday, 5 p.m. When the trigger is set, you can go and update Azure Disks to set the IOPS and bandwidth to the new provision target. When the new target is set, Ultra Disk can seamlessly scale and take effect within 5 minutes. You don't need to reboot your VM, nor do you need to detach your disk. You can scale up and down on your provision performance on the fly. Another way of thinking about flexibility is that your disk can be used for different scenarios. So on-premises, it's very common that you have a cluster of VMs which are sharing a single disk. You do this for 2 main benefits. Number 1, fast failover, because you want your disk to be attached to both of the primary and the secondary VMs, so that when your primary needs to fail over, your secondary can quickly start picking up traffic and start serving the application request. Another reason is that you want to be able to scale your compute independent of your storage, so that you can spin up more compute, more worker roles to work on the data set, where your data set can be on single source of truth, which is one disk. Previously on Azure, to implement such kind of a sharing schema, most of customers normally just set up a leverage storage space direct and set up a storage pool so that it can expose SMB or NFS sharing protocols for shared disk. So today, we would like to announce the limited preview of the industry-only shared block storage on Ultra Disks and Premium SSD. It is designed for clustered databases. For example, if you have Windows Server 2008 failover clusterings, you can now lift and shift that to Azure leveraging shared disks. It's great for parallel file system, for scale-out file server, which I'll have a demo on that, and also great for persistent container volumes. We support read many, single write, and multiple write scenario. The way for us to do that is that we provide the industry standard SCSI persistent reservation. This will allow you to orchestrate multiple writer scenario and still ensure the data is consistent. So let's go ahead and I'll show you a demo on this. So the demo is about how scale-out file server will work best on shared disk. So here, I have logged on to the primary VM of my scale-out file server. You can see that right now the primary is on the VM1. I'm going to show you the nodes. So there are two nodes in this cluster, VM1 and VM2. VM1 as a primary, VM2 as a secondary. Then I'm going to show you the storage setup. So you can see right here on the disks, I have both of the disks attached, and now the owner is the VM1, which is my primary VM. So there are two disks here. Both of the disks are attached to primary and the secondary VM, which I'll later show that to you on Portal. So the first disk is a witness disk, basically capturing the cluster state. The second disk is a cluster shared volume, which basically stores the actual data. Next, I'm going to trigger a failover. So I'm going to go to the nodes and start draining my first VM. So I'll pause it and drain this row, which will force a failover. I'm going back to the rows, and we expect the VMs to quickly come to the secondary. Yes, you can see that now it's failover from the primary to the secondary VM. So the disk is shared between the two VMs so that you can achieve this fast failover. The secondary VM, when it gets elected as a new primary, it can quickly start serving traffic. Now I'm going to show you the portal view. As you can see right here on the two boxes, the same disks are attached to both my demo VM2 and my demo VM4. So the exact same disk can be attached to two or more VMs. So if you're interested in learning more about shared disks and try out this cool new technology, sign up today at aka.ms/shareddisksignup. Ever since we introduced VM reservation instance, we have been hearing feedback that, can we also reserve disks? So today we would like to announce that we're supporting Azure Disk reservation. You can reserve your disk usage in advance. We support a 1-year term on selected premium managed disk SKUs. What is best is that it's leveraging the existing reservation flow, so you can do the reservation exactly as what you're doing by purchasing VMs. You get all the benefits that you have on the existing reservation platform, including cost saving, budget predictability, and then the flexibility to modify your reservations. I'm going to take you through a few examples and show you how this reservation works. Let's say you have signed up for a single upfront payment for a 1-year term. All the disks you have reserved will be shown in the column on the inventory column. So you purchase 30 P30 disks, and you deploy 30 P30 disks. So 100% utilized, you're not going to be charged for anything. Then if you have reserved 15 P40, and then you deployed 20 P40, then you're only going to be charged on an hourly rate of the 33%, which is above your reservation. if you deployed 10 P20, and because we don't support reservation on P20, you're just going to pay on an hourly rate, just as now. Lastly, if you have 5 P50 disks in reservation and you only used 4, you'll not be charged, but we will recommend you to adjust your reservation so that you have better utilization. Besides the cool features I've shared with you in this session, here's a list of all the recent announcements on Azure Disks that we made in the past 6 months and new at Ignite. I would like to highlight one, which is incremental snapshots for managed disks. So this is a new feature which you'll be able to leverage and reduce your backup cost. Because for incremental snapshots, you're only going to pay for the changes between the 2 snapshots. So as I promised, at the end of the session, we will provide you answers to all the comments and feedback we heard from you. Let's go through that. How to choose from premium and standard SSD. Leverage cloud assessment toolsets to determine the workload requirements. This will help you to actually have a more accurate choice when you're choosing between the 2 slices. You can use Azure Migrate, or if you have other cloud assessment tools, definitely go ahead, use that. I need smaller disk sizes for my Linux OS. Try out our preview sizes, starting from 4 GB. I don't want to provision for peak IOPS, neither do I. Why not evaluate a new bursting capability? Basically, you're getting a performance boost without paying any extra. Can I scale up my disk throughput only when needed? Of course, we already support dynamic scaling on Ultra disks. Can I buy reservation for disks, similar as VMs? Sure, you can gain additional saving by reserving disks in advance. You can go to Azure portal today and try out this reservation. Thanks again for coming to this session. So here's a list of all the related sessions on disks and storage. I would like to call out that tomorrow we have a great session on the best practice to improve the performance with disks. We have a great speaker there, so we expect to see you. Thanks again, and please evaluate this session. We'd love to hear your feedback. Me and my colleagues here will stay here for the Q&A. If you have any questions, feel free to follow up. Thank you.